All right, here it goes. I did this at the top of the quiz too. I just gave you the list of the perfect squares, okay? So please use them. They will be up there. Use what you need to use. What do you do first on this first question? -3 rad 5 times, not plus, right? This is multiplication now. Yep, you're going to multiply the coefficients, so that's -6. What do you do from there? Multiply the 5 and the 18. So that's the square root of 90. Okay, what do you do from there? Break it down. So perfect square and non-perfect square, and don't forget about the -6 out in front of all of that. What does the square root of 90 break down to? Which perfect square? The 9. So this is -6 times 3 times the square root of 10, which is -18 rad 10. Any questions on that? I just took the square root of 9, and that equals 3. So whatever the perfect square is should break down to just a whole number. Are you good? All right, number 2. This is multiplication again. What do you do first? Multiply the coefficient. So 3 times 4 is 12. Okay, then you multiply what's under the radical. So 15 times 8, what's that? 120. What is x to the 8th times x to the 7th? X to the 15th. Remember, when multiplying, you're actually adding your exponents. You're not multiplying. Don't make it 56 there. Make it 15. And now you break it down. What is a perfect square and what is not a perfect square? And don't forget the 12 out in front. So you're asking, what is 120 divisible by from this list? Did you find one? What'd you say? 4. There's not a big one here. 4 is the best you can do. So 4 and 30. Because think about 30 has no perfect square factor. Okay. Okay, so what do you do with the x? What's the perfect square from x to the 15th? The 14. You move down 1. There's an x left over. So here's x to the 15th broken down into perfect and not perfect. Okay. So then from there, I feel like this is the place where most people make the mistakes. This is perfect, right? Those are perfect squares. So you need to take those perfect squares. So 12 times what? What does this become? 2 x to the 7th. You're dividing the exponent by 2 when you square root. Okay? And then you still have the square root of 30x. So then just multiply your coefficient, 24 x to the 7th times the square root of 30x.
So is this the only time it's okay to multiply unlike terms?
Multiplication is when you're allowed to do that. If it's addition and subtraction, then they have to be the same.
And what if, like, when we get to
Then that first number you started with was a perfect square. So you should have square rooted it from the get-go on that then. Yeah. Okay, number 3. What do you do on number 3 here? Distributive property. When it's parentheses, hey, when there are parentheses there, you're going to distribute to everything in the parentheses. So you're going to go rad 8 times 3. So that's 3 times the square root of 8. Plus rad 8. What is rad 8 times rad 8? It's the square root of 64. But a radical times itself is always the number underneath. So you could just write it as 8 right now if you see it as 8. The square root of 8 can be broken down to the square root of 4 and the square root of 2. And don't forget the 3. The square root of 64 is 8. So this is 3. Hey, shh, do math. 3 times 2. So 6 times the square root of 2 plus 8. Okay, so if you can break down a radical, break it down.
Hey, but why don't you like add the 8 and 6?
The 8 and the 64. Oh, these. They're not like terms. With addition, so in multiplication, when it looks like this, when everything's being multiplied, then you're allowed to multiply them. But when it's addition, they're not like terms. It would have to be 6 rad 2 plus 8 rad 2 is 10 rad 2s. Okay. So it was 3 rad 8, and you break that square root of 8 down because it has a perfect square factor, right? The square root of 4 and the square root of 2, but then you still have a 3 out in front. So this is 3 times 2 times the square root of 2, so 6 times the square root of 2, okay? Okay, number 4. How do you do this one? Foil. You gotta foil it. So first is gonna be 3 times 4, so that's 12. Outside is gonna be 3 times rad 3, so that's a positive 3 rad 3. What's inside gonna get you? 4 rad 3, so you say plus 4 rad 3. And then the last, you get the square root of 3 times the square root of 3 is what? It's 3, or the square root of 9. If you want to write that as a 3 right now, go right ahead. I think sometimes people don't see it that way, so I'm just going to write it like this and then simplify. So this is 12 plus 3 for those two. And then you have 3 rad 3 plus 4 rad 3. What is that? 7 rad 3. So that's 15 plus 7 rad 3. You can't combine the 15 and the 7 because they're not like terms. You have a radical for one, but you don't for the other. Okay? All right. Number 5 says divide the radicals. Leave your answer in simplest radical form. What's your best move here? There's lots of moves you could do here. There is for sure a best move. 12 divided by 4. Okay, so if you divide this, you get 3. What next? What? Yes. If you don't do 90 divided by 3 right here, you have to rationalize the denominator, and that's hideous. If you can divide this, divide it. This is the square root of 30. Can you break the square root of 30 down into a perfect and non-perfect? So you're done. Okay? You could have gone about that a very different way, which would have required a whole lot of work. Did you do the whole lot of work? Did you get to the right answer? That's good. But you did way more work than you needed to. Okay. So always check first, can you divide it? 32 divided by 3. Oh, that's not right. Is 10.66666. Is that going to work on this problem? No, right? If you don't get a whole number, then you can't divide it. So you treat this like the square root of 32 over the square root of 3. How do you get a radical out of the denominator? Multiply by itself over itself, right? Because we're essentially multiplying by 1. So do that. How do you do this? What do you do first? Multiply the top, and you get the square root of 96. What do you get on bottom? The square root of 3 times the square root of 3 is 3, right? It's the number under the radical. Are you done? You might be. You got to check, is it able to be broken down? So the square root of 96, can you break that into a perfect square and non-perfect square?
Yes.
What? 16 and 6. Okay. What does that become?
4 rad 6.
Yeah, 4 times the square root of 6. replaces this. So you have 4 times the square root of 6 over 3. Can you simplify anything else? That's as far as you can go. What if this was a 6 rad 6 over 3?
You could divide the 6 by 3.
Then divide the 6 by 3. But it's not, so you're just done at this point. Lincoln.
So I did it actually a different way. I simplified the rad 32 first, and I got 4 rad 2 over rad 3.
Mm-hmm.
And then I multiplied 1 rad 3 times 4 rad 2. I can show you.
Did you get the same
I
answer?
got the exact same
Yeah,
answer.
that's fine. You simplified here first. I didn't simplify that until the end.
But I would still get the same answer. Like
Yeah.
you were.
Mm-hmm. Good? All right, number 7. This is what we did today. What's your first step? Subtract 9. You got to isolate the radical. So this is 3 equals the square root of 2x plus 3. What's your next move? Square everything. Square both sides. Square this, square that. When you square and square root, that goes away. So it's just 2x plus 3. This 3 squared is 9. So you're going to take away 3, and you get 2x equals 6, and then divide by 2. So x is 3. Okay. Then you want to check it. Plug that 3 in right here. I'm just going to rewrite it over here. Up here. The square root of 2 times 3 plus 3 plus 9 should equal 12. So this is 6 plus 3. So 9. The square root of 9 is 3. So is 3 plus 9 equal to 12? It is. So that checks out. Okay. What do you do on number 8? Square everything. It's already isolated, so you can square it right away. So x plus 4 equals 81. And then take away the 4. So x equals 77. And again, if you plug that in, 77 plus 4 is 81. So is the square root of 81 equal to 9? It is, so it checks out. Okay, this question, you will see it on your test in a slightly different format, in an easier format. This is the hardest way you'll see it in all 3 situations you'll see it in. But you will see a question like this on your test with this information, and you will see a question like this on your final with this same information. It's really just a matter of, do you understand simplifying radicals, okay? So the first one, it says, in order to simplify radicals, we want to, starts with an S, anything that can be, we want to simplify anything that can be simplified. Okay, so if you can divide 2 parts by the same number, divide those parts by the same number. If you can combine like terms, combine like terms. Anything that can be simplified, you simplify. Okay, that's number 1. The second one, a radical on top cannot have any blank square factors in it. Perfect. If there is a radical on top of a fraction, like 18 over 2, this has a perfect square factor in it. What is the perfect square factor in rad 18? 9. That's not okay, right? We have to keep going. So cannot have any perfect square factors on top. On bottom, what's the rule about radicals? You cannot have radicals on bottom. So radicals on top are fine, but no perfect square factors in them. You cannot have a radical on bottom. And you must simplify anything that can be simplified. You're going to scan it and submit it to Canvas. Yeah, so use your Notability, take a scan, or use Canvas and take a scan and turn that in. Which I feel like the last time a good chunk of you never turned it in. Make sure you turn the reviews in. Okay? I want to give you those points.
Yeah.